Eric Darling here with Darling Data, the start of a brand new day, brand new me, just awakened, refreshed, and renewed, reborn into the world. And we're going to continue talking through the material from my past session. Everything you know about isolation levels is wrong. And we're going to continue on with an overarching theme of this material that read committed is not so great of an isolation level. And I'm going to rehash some points for anyone who is still unclear for whatever reason after watching all the other material. Why, like thinking that it's a great isolation level for anything. It's not. So let's rehash a few points here, and then let's talk about some of the perils of read committed. If Zoomit will cooperate with me. Zoomit was not refreshed and reborn and renewed into this world. Zoomit was just like, we're just waking up. Sorry. Cocaine binge from the night before. So just to go over a couple points again here. Read committed does not give you a point-in-time view of data. And again, it's not that optimistic isolation levels are perfect. No isolation level is perfect for every query that runs and every workload. At some point, you do need to make some decisions in here. Now, what I want to sort of relate this to is like other settings in SQL Server where okay, zoom it, you're really a sleepy one today. When you install SQL Server, when you, or even if you don't install SQL Server, let's say you spin up a cloud version of SQL Server where you still have access to settings, you might make choices based on what you know about your workload for what settings you're going to use to make your workload run as good as possible within reasonable guidelines. For a lot of people, that will be stuff like setting max stop, setting cost threshold for parallelism, setting max server memory, maybe other settings like instant file initialization and lock pages in memory. Some people use resource governor too if they have lots of memory because the 25% default for memory grants is insane. There are lots of great settings that you can use within SQL Server to make your workload run better generally. If we just stick to like the parallelism settings, right? Let's say that in general, most of the queries in your workload work best with, let's just say, a max stop of 8 and a cost threshold for parallelism of 50. Great. You can set those settings as reasonable guidelines for the queries for the majority of queries in your workload. There are going to be some queries that might defy those settings. There might be some queries that go parallel when they just really don't need to. There might be some queries that don't go parallel when they should. There might be some queries that work better at higher DOPs, like 16. And there might be some really weird queries that work better at lower DOPs, like, 5 or 3 or 7 or some odd number that would almost never occur to you to change max stop for a single query to. But these are the kind of things that we have to take into consideration for isolation levels too. There might be tons and tons of queries in your workload that work great, probably better under an optimistic isolation level than they do under a pessimistic isolation level. And there might be some edge case queries that don't work the way that you intended them to under an optimistic isolation level, and you have to add some sort of locking hint to those queries. You might even have to use a different optimistic isolation level. Like you might have queries that work fine under snapshot, but don't work the way you want them to work under read committed snapshot isolation, which is a comparison that we'll make in a little bit. But there are all sorts of things about your workload that you need to know about and you need to be able to make adjustments for. Now, if you have a third-party vendor workload and you can't make those changes, I do sympathize, because getting third-party vendors to use optimistic isolation levels is sort of like getting a kid to brush their teeth. They will make every excuse in the world to say that they don't need to do it, right? They'll just fight you until the next morning about brushing their teeth. But So like you do have my sympathy if you're in that situation, but a lot of the vendor hesitancy around optimistic isolation levels just comes from a place of complete naivety and ignorance. A lot of them are just so god awful bad at databases, and especially bad at SQL Server and understanding isolation level stuff in SQL Server, that they're in no place to tell you no about these things. They have absolutely no wisdom about these things, where they should be saying no, it would cause problems. Because a lot of them just have no clue. They are just clueless people. I've seen a lot of vendor applications for SQL Server. They are not written by people who know anything about SQL Server. They are not written by tender, loving, caring people. They're written by buffoons, and I honestly don't know how they ended up being successful, and people pay money for these things. It is insane to me to see some of the quality of code that ends up as third-party applications. So to go over things a little bit, that went on a little longer than I intended, but to go over things a little bit here, there are things that work differently between pessimistic and optimistic isolation levels. But very, very few workloads actually rely on those differences for correctness. Many, many vendor workloads are already using a crapload of NOLOCK hints. And again, reiterating some points, making sure that we're going to make sure that these things sink in via repetition. Right? We're going to do our 5 sets of 29,000 reps on these. Read committed. The pessimistic default isolation level can show deleted rows, see rows twice, miss rows entirely. All sorts of read phenomena happen under read committed that vendors will accuse of only being able to happen under optimistic isolation levels, which is absolute just rank nonsense. Modifications under read committed can happen before and after read queries release their tiny little locks on the rows or pages that they finished reading. There is, under most circumstances, I just want to reframe this a little bit, under no circumstances, there is usually no lock escalation for read queries. We'll talk about a couple instances where there are a little bit later, but you can use more strict isolation levels like repeatable, read, and serializable to prevent the type of read phenomena that happen under read committed from happening. Some query plan shapes will cause read queries to take and escalate and hold read locks until they take an object level shared lock. And those can cause a lot of blocking and deadlocking problems. But for now, we're going to go back into flash mode. And I am going to show you some of the perils of read committed under concurrency. Now, these are the types of consistencies that can happen under read committed. Again, this is the default isolation level. This is not an optimistic isolation level. This is read committed. This is your precious read committed that everyone wants to just stick with, except all the NOLOCK, right? So let's just take a quick look at this. So one thing to keep in mind, and this graph doesn't frame up terribly well at this zoom, so I'm going to zoom this out a little bit just so it fits a little bit better on the screen. So under read committed and read committed snapshot isolation, note that even though one is optimistic and one is not, they both allow for the same read phenomena to occur. Under read committed and read committed snapshot isolation, you may not see dirty reads at all for either of them, right? Because read committed guarantees that you will only read committed versions of row data in your table. Read committed snapshot isolation does the same thing. Where both of them have read phenomena that can happen is non-repeatable reads and phantom reads. But this is, again, this is common to both of them. This is not just for read committed snapshot isolation. They both allow this. If you want to use an optimistic isolation level that prevents that, the only one to use is snapshot. Again, we're going to talk about those differences in a little bit, but first let's talk about what each of those read phenomena really means. We're going to bump this back up to 150. So a dirty read, of course, this can only happen under read uncommitted / NOLOCK, right? Again, synonyms for one another. A dirty read is if a transaction reads data that has been modified by another concurrent transaction that has not yet committed, right? So that transaction is in flight. It has not reached the point where it has fully completed whatever it's doing. It is not committed and it has not rolled back, right? So it is just in flight. A non-repeatable read is if a transaction reads, like we just pretend this is if a transaction read the same row twice, one after the other, right? So a transaction reads the same row twice and finds different data each time. So there's no lock on that row that prevents changes to that row as the read is happening, right? Or after the read happens. Phantom reads are if a transaction retrieves a set of rows twice, again, pretending that we read the same results, read the same rows that we care about twice, and either new rows appear from another transaction. Serializable does prevent this by not allowing transactions to remove locked rows, but new qualifying rows may be inserted or updated. All right. So let's look specifically at all the crap that can happen under your precious read committed isolation level. First, we're going to make sure nothing weird is going on. We are already in the right database, and we're going to create this table called read committed stinks. But first, we're going to drop that table so that we can create it. Now we're going to have a much better time. Now, there are a couple of things in here that I want you to pay attention to. One is this account geez Louise, zoom it, you really are having a tough time today. One is this account ID column, right? Because this account ID column is defined as unique, okay? That means it does not allow duplicates, and there is an index on this column that disallows duplicate rows. The second thing is that we have a unique index on first name and last name, okay? So we have three things on this table that will prevent duplicates from showing up. The primary key index, right, up there, the unique index on account ID, and the unique non-clustered index on first name, last name. So now what we're going to do is put some rows in this table here. And these are actual brunch prices from a menu in New York. You can be as astounded and amazed as you'd like by these prices, but this is just what we deal with in New York when we go to brunch. So if you ever wonder, you know, how I maintain such reasonable rates on consulting with these kind of brunch prices, I do a lot of sacrificing for the SQL Server community. All right, so don't say I never did nothing for you. All right. So we've got those rows in the table. Let's just see what the table currently looks like. Right, we get all these things back, and this is just a nice SSMS tabular format of what you just saw me put in there. All right, you can even see what today's date actually is. It's amazing. He's recording things in the past for the future. So I've already got these queries over in this SSMS tab, and we're just gonna take this and unquote that. The go-to makes all sorts of weird things happen to SQL prompt when I try to like auto add semicolons, so I leave it quoted out in the main script and unquote it out over here. But what we're going to do is, again, I am the Flash. And as the Flash, I am going to pretend that I ran this query right here. I started a transaction, and this update is running. All right, and at the very same time that this update begins a transaction and starts running, over in this window, we do this. Right, so the go-to means this query is going to run twice, and the lack of a go anything means this query is going to run once. Right now, this select query, the first one that's trying to run, that's looking for account values greater than $999, is blocked. It's not able to make any progress because we have run an update to update where ID equals 7. So that read query read through the first 6 rows of the table and got stopped on ID 7, the 7th row of the table. So 7, 8, 9, and 10 have not been read yet because this row is locked, and under read committed, that query cannot read that row until this lock releases. Now, in grand Flash fashion, while that update is running and doing stuff, other modification queries are going to come into the database and touch other primary key rows, which are also not going to be blocked by this. So we could update rows 1, 3, 4, and 9 and give them an account value of 999, and also set, remember for all these we're going to also set the last activity date. We're going to update ID 6 and change the ID to 11, right? So we're actually going to flip primary key values on this one. We're going to do that one more time, and we're going to set ID 10 to ID 6. So we're actually just changing the place of ID 6 at this point. Now we're going to delete rows 2, 5, and 8, and we're going to come back down here, and we're going to actually reinsert 3 rows for IDs 2, 8, and 10 down here. Okay, so we're reinserting 3 rows, and then magically, whatever this update is now about to finish after all those other updates have occurred, and this transaction gets committed. Okay, and once that gets committed, everything over here happens instantly, right? We get results instantly back. So let's compare. This is the first result. So this is the one that got blocked when, excuse me, let me make this a little bit wider, frame that up a little bit better for all these. Actually, those two are fine. So this is the first result that got blocked when we read row 7. All right? This is the first thing we see. Notice that even though from this bottom result, this is the final, this is what the full table looks like now. We were missing last activity dates for stuff that we set last activity dates for. And we have some really bad looking data in here. So remember, we have a unique index on account ID, and we have a unique index on first name, last name. But in our results, we have 2 instances where there are duplicate account IDs. We have 2 1005s and 2 1006s, and we have 3 cases where we have duplicate first name, last names. We have 2 steak frites, we have 2 Bloody Marys, and we have 2 Scotch eggs. Now remember that our query was looking for where values are greater than 999. We reduced a bunch of the account values in here while this query was blocked. So the second time this runs, okay, the first time this runs, it returns 9 rows. The second time this runs, it only returns 5 rows. So there are 4 rows that are technically incorrect in this result set, but we still see them in the first result set that got blocked because we already read the higher account values for those things than they got modified down to. So read committed can really actually return a lot of bad information if your query gets blocked at just the right time and other queries are allowed to get in and do things. Keep in mind that all those other queries that ran, under normal concurrency, all those other queries would be allowed to run and do stuff. And if they just happened at the right time, your initial read query would return all sorts of just bad bunk data. If we just compare the rows that come out of the first result and the last result, we get just the stark differences between what was in here and what was in here are right. It's huge, right? Just a lot of stuff is different. Look at all the 999s in here. There weren't in the other one. Look at the 5. I don't know. Just a bunch of stuff is different. Read committed is not that great. There are a lot of bad things that can happen under read committed that people tend to solely and purely associate with read committed snapshot isolation. So. We'll scroll down a little bit too far there. Anyway, the read committed allows for a lot of phenomena to occur that a lot of people don't expect. What a lot of people might say, oh, that'll happen under an optimistic isolation level because it allows blah, blah, blah reads. They're wrong. They have been misinformed. They are terribly misinformed people. And they are usually people who have just read a couple blog posts, decided that they are experts on isolation levels now, and are going to stand there, hands on hips, trying to tell you better about things that they don't know about. And what's especially depressing is these are the same people who will have no problem using NOLOCK hints or read uncommitted everywhere. And these are the same people who, when you go to them about blocking and deadlocking problems between read queries and write queries, they try to blame you for something. They start talking about index fragmentation. They go through like the entire L1 run book of like SQL Server excuses without doing anything that will actually address the problem, and without like bending even just a little bit on using an optimistic isolation level to resolve those problems. So anyway, we're going to move on from here, and we're going to look in the next videos. We're going to look at read queries and write queries blocking and deadlocking with each other, and then I forget what's after that, but that'll be fun too. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned something. I hope that you are finding this series illuminating and educational, and that you will continue to watch, and that you will be able to use these videos in your arsenal against again, SQL Server idiocy when it comes to isolation levels. Anyway, I think that's about it on this one. So, yeah. All right. Goodbye.